Hi, so for this lesson, we are looking at derived units in unit analysis. And I kind of tricked you in an earlier lesson, and you have already been doing some unit analysis. For example, when we went and said, how many centimeters are in 5 meters? So you had to say, what did we want? We want centimeters, and what have we got? We've got meters. And you looked at your metric conversion chart and found that 1 centimeter was equal to 0.01 meters. We canceled out what we were given, and we were able to solve this and say, hey, that's 500 centimeters. Now, we're going to get a little bit more complex because when we're looking at derived units and unit analysis, we're looking at those that maybe have a ratio or fraction of units. For example, if I said the speed limit on, let's say, the back highways is 55 miles per hour. So we're not just going from 55 miles to kilometers. We have 55 miles per hour. So we're going to set it up similarly to what I did up above here, but I'm going to write it in fraction form, 55 miles per hour. And since it doesn't say, we're assuming that somebody is traveling 55 miles in 1 hour. I could also write this and the reciprocal version of this, and I'm going to do it over here to the side, and I could say in 1 hour, somebody has traveled 55 miles. Right? Those are equivalent. They're just reciprocals of each other. So then what I need to do is, okay, what do I want? How would you convert this to meters per second? So my final answer, I need meters per second. That's what I need to get to. So I need to go from miles to meters and hours to seconds. So we are given, it says, note, 1 mile equals 1,609.3 meters. So let's write that conversion factor. And down here, we're going to say that 1 mile is equal to 1,609.3 meters. We could also say, or 1,609.3 meters is in 1 mile. So now we're going to use one of these two conversion factors up here. I need to get rid of miles. Here's miles. And remember, in order to get rid of miles, I need to have it diagonally down here in order for them to cancel out and to cross them off. So if I have miles down at the bottom and I want meters, look over to the right, I need meters on top. So I need to use the conversion factor that has meters on top, miles on the bottom, which is not this first one, it's this guy. So I'm just going to write this conversion factor right here, 1,609.3 meters in 1 mile. Well, that'll cancel my miles out. Okay, so now if I solve my problem right here, I would have meters per hour. I don't want meters per hour. I want meters per second. So I need to get rid of hours. So in order to do that, I'm going to need another set of conversion factors. I need to go from hours to seconds. So let's just figure out, well, how many seconds are in an hour? There are 60 minutes in an hour and 60 seconds in a minute. So 60 times 60 is 3,600 seconds for 1 hour. But I can also say that in 1 hour, there are 3,600 seconds. So we need to use one of these two conversion factors for right here. Which one do I need? I need the one, since I'm starting with hours down here on the bottom, I need to have hours on top so that they will cancel out. I also know that I need seconds on the bottom because my answer needs seconds on the bottom. So I need to use the conversion factor with hours on top, seconds on the bottom, this guy. 1 hour is 3,600 seconds. So now what I need to do is I just need to, let's see, hours and hours will cancel, and I'm going to be left. My only unit on the bottom is seconds. My only unit on the top is meters. So when I multiply across 55 times 1,609.3 times 1, all divided by 3,600. I get a number on my calculator. I get 24.58652778 meters per second. Now, it is important to then look back at my problem and see how many significant figures did I start with. I'm not using my conversion factors as a significant figure factor, because remember, this 1 mile is equal to this many meters is an exact number. So I'm going to look back and say, okay, well, I started with 55 miles per hour. That has 2 significant figures, so I want to finish with 2. So I'm going to say, okay, 24.5, that 5 will round that 4 up. So we're going to end at 25 meters per second. Would be my answer here. Now I want you to try setting this one up on your own. If a motorcycle is traveling at 105 kilometers per hour, what is the speed in meters per second? I gave you the 2 conversion factors we need. I want you to try going through all of the steps of writing out our conversion factors and the reciprocals and figuring out what to do. So pause the video, and then we will go through to make sure you set it up the same way. So I wanted to make sure, did you set up your 105 kilometers for every 1 hour? To get rid of kilometers, I needed to have kilometers down here, and we know that 1 kilometer was 1,000 meters. So I used 1,000 meters over 1 kilometer. Then I wanted to get rid of my hours. So I used the conversion factor of 1 hour, there are 3,600 seconds. So when you plug this into your calculator and you multiply across and you divide going down, your calculator gives you this big answer. And again, we need to be careful to not finish there. We need to go back and figure out how many significant figures did I start with. And I started with 3, so I need to finish with 3. So I'm just going to say, okay, that 6 is going to do what to that 1? 29.2 meters per second, and then circle your final answer. Now, another problem. Let's say that I have an automobile battery, and I'm given that it contains this many grams of acid. The density of battery acid is this many grams per milliliter. So I'm given the mass and I'm given the density, and it wants me to find the volume. Now, there's 2 ways that we could do this. If you don't remember the density equation, we can do this doing unit analysis. I'm going to show you how to do that first, and then I'll show you how to do it if you remember the algebraic equation for density. So again, we're going to start with what we're given always. 2,346 grams of acid. Now it tells us that the density is 1.84 grams per milliliter. Again, we could write it just like this. That per is our dividing line. And so it's saying that for every 1.84 grams, that takes up 1 milliliter. Or we can say 1 milliliter, and 1 milliliter is 1.84 grams. So we need to figure out, what do we want our answer? We want our answer just milliliters. What is the volume? So we need to figure out what conversion factor we're going to use in order to get just milliliters. So if I'm starting with grams, I need to have grams in my denominator in order for grams and grams to cancel. And if I want milliliters, what do I want over what I've got? So I need milliliters on top and grams on the bottom, which is not this first one. I need to use this conversion factor. 1 milliliter, 1.84 grams. So to solve this one, we would do 2,346 times 1 divided by 1.84, and we would get 1,275 milliliters. But remember, we need to look back at sig figs. I have 4 significant figures for my mass, and I have 3 for my density, and this is a multiplication problem. So I can only have 3 in my final answer. So I'm just going to say, all right, that 5 is going to make that 7, 1,280 milliliters, and I want to circle my answer. Now, we could also do an algebraic equation. Density is equal to mass divided by volume. This is always kind of tricky for me to rearrange algebraically, and I know a lot of people struggle with it. In a previous video, I showed you this. Density, mass divided by volume. And you cover up which letter or which variable you want to find. So in this case, it's asking us to find what volume. So I'm going to cover up this volume. So I'm going to say V equals M over D. Mass divided by density is how we would rearrange this equation. So I can say, okay, my mass up here was 2,346 grams. And the density that it gave me was 1.84 grams per milliliter. And if you do the math, you're going to get the same 1,275 milliliters, which we would still need to do sig figs. As you can see, our unit analysis gets us to the